So the last problem we did sort of hinted at this, but we're going to come up with a distance formula in 3 dimensions. And so the way I'm going to do this is first I'm going to start with, imagine you've got x, y, z. We have the origin here. And I've got some point in space, and this is the point x comma y comma z. And I am interested in the straight line distance from one to the other. So what I'm going to do is I'm going to redraw this the way I did before. And I find this sort of other orientation of 3-dimensional space can be useful when trying to figure stuff out like this. So I'm going to do in blue, I did this before, I'm going to draw dotted lines. And you've got the point here, x comma y comma z, and we're interested in this distance. So there's my cat again. Hi, Mimi. So you can't see anything, but Mimi is like a 13-year-old tortoiseshell. And she is loud, and I am in her domain. All right, so let's see. So this is the point 0, 0, 0. And just like before, I'm going to think of this right triangle where this is x comma y comma 0. So sort of redrawing that over here, I've got the point x, y, z up here. I have the point x, y, 0 down here. And this is the point 0, 0, 0. So I'm going to go to a new slide, and I'm going to redraw this whole thing. And we're going to figure this out. So as before, and I'm doing this in red again, this line has length z. And so the real interesting question is, what's the length of this line? So if we draw the xy plane, here's xy 0, and here's 0, 0, 0. We're talking about this distance there. So this line has length x, this line has length y. So how long is the hypotenuse? Well, the hypotenuse must have length square root x squared plus y squared. So that means that this line up here has length square root x squared plus y squared. And so that means that the number L we're looking for is the square root of x squared plus y squared squared plus z squared. And if you do a little bit of calculation, you get x squared plus y squared plus z squared. And that's your distance formula. Notice that it looks exactly like the distance formula in 2 dimensions. It's a Pythagorean theorem identity, basically, except with 3 variables in it instead of 2. And we're not going to talk about higher dimensional space and 3-dimensional space as well, but this analogy continues. If you can imagine 4-dimensional space with 4 variables, the 4th variable is usually a w, then the distance formula there is x squared plus y squared plus z squared plus w squared, and so on and so forth. So that's the distance from a point to the origin. So it stands to reason then that if I want to figure out the distance between the point ABC and the point XYZ, so I'm going to get the same sort of cube picture I do before, and this point over here is x comma y comma z, and this point down here is a comma b comma c. So then what we can do is we can actually play a fun game where we try to figure out the coordinates of this point right here and this point right here. I gotta declare some directions. So let's say that to the right is X, as we've been doing, into the back of the paper is Y, and straight up is Z. So the only thing that changes from ABC to this first point here is the X coordinate, because we're moving on the X axis. So this must be XBC, which means this must be XYC, which means this must be XYZ. So then, this distance on the square is X minus A. This distance on the square is Y minus B. And this distance on the square is Z minus C. So now we know those lengths. So now I should be able to figure out the diagonal distance between my 2 points. So why don't you think about that for a second. Pause, work on it for yourself for a minute. And then when you unpause, I will have the solution for you. So I'm going to go to a new slide now. So what I've got is I have the point, keep doing this. This is ABC here. This is XYC here. This is XYZ. And this hypotenuse is the length I'm looking for. This is Z minus C as always. And if we think about it, this length here if I started at ABC, and again, I'm looking at the XY plane, this distance here we're looking for, well, the base of the red triangle here is X minus A, and the height is Y minus B, which means this length here is the square root of X minus A squared plus Y minus B squared. And so then, if this is L, you can work out pretty quickly that L should be the square root of X minus A. So I'm not going to have room for that. Hold on a second. Let's try it one more time. Let's see. Let's try L equals X minus A squared plus Y minus B squared plus Z minus C squared, and then I take the square root. And so here's your distance formula. Again, it looks exactly like the two-dimensional one, except there's 3 pairs of coordinates instead of 2 pairs of coordinates. Okay. And so using this, we can figure out the distance between any 2 points in space.